All right, so we're making our way through chapter 9. We are down to our last two lessons. This is lesson 9.7, solving our quadratic equations, just like we did in, there's my dog scratching at her collar. Just like we did in the last lesson, we factored to solve. Now we're going to solve by using square roots. I will venture to say that this might be one of your favorite lessons of the chapter, so you'll have to let me know what you think. All right, so solving using square roots. This is when you have an x squared in your equation. And if you notice, there's no other x's in this. It's just an x squared. We have to solve this, and I can't even remember if we've talked about solving equations with square roots before. So let's think about this. What number would you square that would be equal to 100? The easy one that we come up with is 10. 10 squared is 100, so x is equal to 10. Now, the thing that we have to keep in mind that we may not realize is there is another answer. There's another number that you can square that will give us 100. And what you want to remember is when you square negative numbers, a negative times a negative, it comes out positive. So negative 10 squared also equals 100. So we get two answers for x on these. Just like when we factored, we got two answers for x. When you solve using square roots, you could get two answers for x. The mathematical way of solving, we have a squared. The opposite of squaring is taking the square root. A square root cancels out a squared, leaving you with just x. Now, if you're going to square root the left side, you have to square root the right side. And the square root of 100, let me kind of separate that. Square root of 100 is 10. But how can we already know that we should have two answers down here. So this is the thing we have to remember on our own, is that positive 10 is the answer and negative 10 is the answer. So you could write it out separately like we did below, or kind of a shortcut way to write it is to put a plus and a minus in front of the 10. And that means that x can equal a positive 10 and a negative 10. All right, so these will get faster. This is just kind of, I'm explaining a couple things here. Next one, x squared equals negative 81. Well, if we follow our same logic on the last one, you can undo a square by square rooting. So let's go ahead and square root both sides. So the square root of x squared is just x. And now we run into, can you take the square root of a negative number? If you try it on your calculator, you're going to get an error message. So we actually can't do this. So we would say no solution, because you can't square root a negative answer or a negative number. And if you think about what number can you square to get a negative 81, the reason why you can't do it is anytime you multiply a number by itself, if it's positive, it turns out positive. If it's a negative times a negative, it also turns out positive. So you can never get a negative answer if you're squaring something. So on these, if you find that you have to square root a negative number, we just stop and say no solution. Now, what does this have to do with our graphs of our parabolas? Remember, when you solve for x, you are finding the x-intercepts. That's why this one has two x-intercepts. It crosses the x-axis at 10 and at negative 10. Now, on this one where we say there's no solution, that's because this graph doesn't even cross the x-axis. There are no x-intercepts. So you can't square root a negative number because this one, they just don't even exist. All right, let's move on and do some equations. So what you're going to like about this lesson is it feels like you're solving a regular equation. You have to get the x squared by itself before you take a square root. So just following our equation solving, we're going to subtract 3, do that addition or subtraction first. So 2x squared equals 98. And then you have to get rid of the 2, so we're going to divide by 2. So x squared is equal to 49. Now that you have the x squared by itself, you can square root both sides. The square root of x squared is x, and the square root of 49 is 7, but remember, we get two answers on these when you square root an x squared, so positive and negative 7. One little trick you can use to remember that is you see how the equation has an x squared? That can remind us that we have two answers, positive 7 and negative 7. See how nice this is? All right, next example, we have to get this x squared alone, so do your addition or subtraction terms first. We're going to add 10. So you have negative 4x squared equals negative 4. Now let's get rid of the negative 4 with division because it's being multiplied by the x squared. So we have x squared is equal to a positive 1. And then we go ahead and square root both sides. Square rooting cancels out the squared on your x, leaving you with just the x. And the square root of 1 is 1, but we have two answers, so a positive 1 and a negative 1. All right, so we have a few more examples because there's some different things that happen. I just want to make sure we recognize it in an equation. X squared plus 12 equals 8. Solve for the x squared. So let's get the 12 to the other side. We're going to subtract 12. So we have x squared equals 8 minus 12 is a negative 4. And now what you notice is we're square rooting both sides to solve for x, but here's this square root of a negative number. You can't do that. So right now we know that there's no solution. And again, what that means on a graph is you don't have any x-intercepts. All right, let's do another one. Solving, let's get the x squared alone. So we're going to add 8. X squared equals negative 17 plus 8 is a negative 9. And then we go to square root and we say, oh, can't square root a negative 9, so no solution. Be careful with that negative. I will see students kind of forget that it's there because the square root of 9 is 3. And they'll tell me, oh, it's a positive and negative 3 because we just weren't paying close enough attention to see that you do have a negative right there. All right, so these two examples have something even a little bit more different happening, so I want to make sure we know how to do this. Again, just solve for x. We're going to subtract 17 from both sides. So 81x squared equals 64. Then we divide both sides by 81 to solve for x. So x squared equals, and then maybe we get a little bit bothered by this fraction over here. Well, don't worry about that. Let's just leave it as 64 over 81. That's okay that it's a fraction because you can, to solve for x, you can take the square root of x squared. You can also take the square root of a fraction. So this leaves you with x equals, so what happens when you square root a fraction? I'm going to kind of show you every step. You can square root the top number and you can square root the bottom number. So what's the square root of 64? That's an 8. What's the square root of 81? 9. So x is equal to 8 over 9. But don't forget the plus or the minus. So you might solve for x squared and get a fraction. That's okay. Just keep following through with your solving. Square root both sides. And then you'll get just, chances are it's going to be numbers you can take the square root of. And then you'll get that nice fraction right there. All right, next one. Solving, get the x squared alone. So subtract 9. So we have 9x squared equals 16. Let's divide it by 9. So x squared equals, well, 16 doesn't divide by 9, so we'll leave the fraction. But remember, to get x squared alone, you can square root both sides. X equals, and then let's take the square root of 16, which is 4, and the square root of 9, which is 3, and then plus or minus out front, so we get our two answers. All right, this is our last slide. I just want to tie this in with the graphing we've been doing. Now that we know how to find x-intercepts, we can use those on our graph. We did this with our factoring video, so let's take a look at what it's going to look like with this type of equation. So finding your axis of symmetry, x equals negative b over 2a. If you notice, our b value up here is missing. We don't have the b. So that means that our b is a 0 over 2 times 4. Well, 0 divided by anything is 0. So x equals 0 is our axis of symmetry. On the graph, we can go ahead and draw that in. Let's see, I'll use that one. Oops. Here's our axis of symmetry. All right, now the vertex, we plug in the 0 for the x, because we know that that's the same as the axis of symmetry. So y equals 4 times 0 squared minus 16. You do the math and you get negative 16. So there's our vertex. So I guess on my graph it only goes to 10, so I'll count by 2's. I'm going to go to a negative 16, but counting by 2's, let me zoom in a little bit, is going to give me down 2, 4, 6, 8, 10, 12, 14, 16. It's going to put me right there. So let me go ahead and put in that point. There's my vertex. All right. So now let's go back to the y-intercept is when you plug in a 0 for your x. Well, plugging in a 0 for x is actually what we just did. We just plugged in a 0 for x, so I already know that we're going to get 0, negative 16, which we also just plotted. So some of these examples, if your axis of symmetry is on the y-axis like this one, that means that your vertex will be on the axis of symmetry and your y-intercept will be the same point as your vertex. All right, so we need some more points to graph, so let's go ahead and find our x-intercepts. X-intercepts is when you plug in a 0 for y, so 0 equals 4x squared minus 16. Now how do we solve for x? If you notice, all you have is the x squared term. If that's the only x, you can solve for it. You can add 16 to both sides. So we have 16 equals 4x squared. Divide both sides by 4. So x squared equals 4. Then you can square root both sides. So x is equal to a positive and a negative 2. If we write those out as intercepts, you have a 2, 0, and you have a negative 2, 0. So that gives us 2 more points that we can put on our graph. So the 2 more points we have is a negative 2, 0, and a positive 2, 0. And now we can draw in our graph, our parabola, since we have, basically, knowing how to find the intercepts gives us more information about our graph so we can have a nice accurate parabola that we're drawing. And there you go.